Alright, let's talk about the properties of determinants. Alright, so there are some very useful properties of determinants when it comes to actually computing determinants. Alright, so let's look at the first one. Alright, if you multiply a row or actually a column by k, so some constant, then you know that the determinant of the matrix is going to be multiplied by k. Right, so maybe I should write it as multiply row column by k as well. Right, so if you multiply an entire row by k or multiply an entire column by k, then the determinant is multiplied by k. Right, and number two, right, when you have these conditions, then determinant is always equal to 0. Right, so here. This means that determinant is always equal to 0. Right. First, if you have a 0 row or 0 column, right, then the determinant is automatically equal to 0. Or if you have identical rows and or identical columns, then the determinant is 0. Or it doesn't have to be identical, it just have to be actually proportional to. So one row is twice as big as this another row or something like that, then the determinant is always equal to 0. Right? Then if you exchange rows or exchange columns, then it changes the sign. So the this becomes determinant is going to be negative of the original determinant, right? So it changes sign. So every time you switch row or switch column, it changes sign. So if you switch rows twice, then it doesn't change sign, right? And also another row operation, multiply row j by k and add it to row I, then this will not change the determinant. So determinant unchanged. Right, and another one is that if you take the transpose of a matrix, the determinant of the transpose of A is actually exactly the same determinant as before. Alright, so those are the properties. So some operations do not change the determinant. Some change its sign. If you multiply by a row by a number, the determinant you have to multiply by the same number. Or if you have a 0 row or identical row or proportional rows, then the determinant is equal to 0. Alright, so let's look at this example. We're going to actually use some of the property to make our life easier when it comes to finding the determinant. Alright, so as we said in class, having a 0 is a good thing when it comes to finding the determinant. So what you can do is, let's look at this one right here. All right. So you have a 0, so we would like to use this guy. And what we want to do is, let's say I'm going to expand along the row 3, right? But the row 3 has one non-zero, there are two non-zero values, right? We can actually get rid of this 3 by using a column operation, a row operation, a column operation. And I guess I should have run. This is true with the column operation, right? We usually do column row operation, but you can do a column operation as well, right? So for example, we can get rid of this 3 by take column 2, multiply by negative 3, and add it to column 3. That becomes new column 3, right? So the determinant is going to be unchanged, right? Matrix is, of course, is different, right? So we have first column is unchanged and second column is also unchanged, but we multiply this guy by negative 3 added to 1, so that will be 4. Right, 2 times negative 3 is negative 6, added to 1 is negative 5. Right, and 1 times negative 3 added to 3 is 0. Right, this is what we wanted, right? right? Then we're gonna expand it along this row, right? Then all you really have to do is this. So this is going to be 0 times cofactor 3, 1, all right, plus 1 times cofactor 3, 2, plus 0 times cofactor 3, 3, right? So you can see that since there are a bunch of zeros, this is going to be 0, so we can just scratch that out, and this is going to be 0. So all we have to do is find that, right? So this is going to be, right, 3 plus 2, so it's going to be, maybe I'll write that, so it's 1 is 1, so negative 1 to the 3 plus 2, which is going to be just negative 1. And then we have to look at the minor 3, 2. Alright, so let's compute that. So this is going to be negative. Then minor would be 3, 2. So we're going to scratch out the 3/3 row and the second column. Alright, so what you get is 1, 4, 2, negative 5. Right? So this is going to be negative, right? 1 times negative 5 is negative 5, minus 2, 4 times 2 is 8, right? So that therefore it's negative 13 with a negative sign, so it's going to be positive 13, right? So it might be useful to apply row operations before you find the determinant. So row operations, sometimes you get a bunch of zeros, then the computation using the expansion is gets a lot more simpler. All right, that's it. I hope that this was clear.